Well, now that's interesting. That's really interesting. That's putting it way back further than I've heard. That's really quite interesting. In any case, my understanding was that we didn't have the concept of zero until way after the year that would have been zero. So when you went from BC to AD, they didn't have zero. And so as a result, in the historical record, you have year one, when there actually should have been a year zero in the middle, but we didn't get that. But in any case, zero wasn't around, the Arabic numbers weren't around, so when did that first start affecting mathematics? But clearly in the Greek books, they used their alphabet, because alpha was 1, beta was 2, delta was 3, gamma was 4, I remember what iota was 10, etc. Right? And sometimes they put a line over the letter to indicate that it was a number, but often they didn't. So basically, you had to use context in order to know when they're using numbers, etc. That's interesting. Okay. Is this interesting, by the way? When you think about, you can think about this all day long. When you hear somebody say something and you think, aha, that's a true statement. How do I know it? What are the corresponding subject predicate? And by the way, in grammar class, you probably got the predicate is the action that the noun is taking. Obviously, in this system, that's not really what the predicate is. I can say, I'm walking. And that was true for a few seconds, right? And I'm the subject of that statement, and walking is the verb, right? Well, how do you figure that that's a true statement then? Well, the predicate is everything that is walking. I'm in the set of things that are walking, right? See how you can do that, right? Well, a characteristic of this, and this is a very Greek problem, is that there's the verb to be in all four of these. So you're saying this set is in this set, right? In fact, I think they have the Venn diagrams on this page too. I think they do. Why not? Well, let's just go to Venn diagrams here. John Vann, notice he lived in England, 1834 to 1923. Aristotle doesn't use Venn diagrams, obviously. Odd example there. But when you use these to talk about the four types of statements, you end up with these four types of Venn diagrams. So for example, this one, you're saying that for anything you pick, if it's in this set, it's also in this set. So you fill in this area to say, see, all of these are also in these. So all horses are also animals, right? There's no horses over here that aren't part of animals, and there's no, well, we're not really going this direction. What the heck is this one? Union of two. Well, I don't want to go there. Let's not do that one. But you're saying this is equivalent. The two are equivalent, I would think. I don't know what the heck they're doing with that. Interesting. I thought immediately, as soon as I saw four, that they would be the ones that I'm, well, there's other aspects to that too. But you can use the Venn diagrams to represent those 4 statement types. So that's a nice feature of the Venn diagrams. And then you can put them together in arguments, by the way, which is the next step, really. If you have an argument, and this comes from the Analytica of Aristotle, that having a true statement is one level of expression, right? This is a true statement. But I can also have an argument, he says. And an argument would not be just one statement. You're just yelling and screaming if you're saying it over and over again. That's not really an argument. Right? If I have a second statement, all horses are animals, all cows are animals. Okay, well, that's 2 statements, both of which are true, but I don't have an argument there yet. Right? If I say all horses are smart, no cows are smart, therefore no cows are horses. That's actually a valid argument, right? I'm pretty sure. I did that really quick, but that should be right. But I mean, it's also unusual because we're not really very concerned about proving that cows and horses are not equivalent, right? But notice what I did is I had 3 statements of the form A, E, I, and O, or O, right? And by putting them together, I end up with a particular type of argument form. And you can go that's the easiest way to do this. So when you put 3 statements together to form an argument, what you've done is you've created a syllogism. So a syllogism has to have 3 statements. Here's another example. All men are mortal. Socrates is a man. Therefore, Socrates is mortal, right? Well, Aristotle will put together a book that shows you all of the valid forms of arguments. And most of them are invalid. So when you look at all the possible forms, and what are they? You have 4 types of statements. So if you have 3 statements, you can have AAA, or AEE, or AII, or AOO, or OAI, right? You get the idea? Any of those 64 possible combinations of 3 letters, right? Plus, when you put them together in an argument, you also will have a particular form of the argument, and the form of the argument will be one of 4 types, where the predicate and the subject will fit a particular pattern, and you can have 4 of those. So you end up with 4 times 60, so you get 256 possible syllogisms, of which only 24 are going to be valid forms according to Aristotle. And you can easily go and look, sorry. So those are the figures, right? So here's the 4 figures that you could have. And what's the M? Where does the M come from? The M stands for the middle term. Because in any argument that's a syllogism, you have the subject term, the predicate term of the conclusion, and then you also have a middle term, which is one of the terms used in each of the 2 premises. In any case, you have 256 possible types. Only 24 are valid according to Aristotle, really, and according to the modern according to the modern version, because they cut out some of, because they cut out some of the relationships on the square. And why do they do that? Okay, let me quick explain. In modern languages, when we say something like, all unicorns have a single horn, and is that true or false? All unicorns have a single horn.
True.
It's true. Okay. Therefore, some unicorn has a single horn.
No.
No, because why?
That kind of implies that not all unicorns have a single horn. Because like, if only some of them do.
Good point.
Yeah.
Good point. The other problem, though, is it also seems to imply the existence of an actual unicorn. In a modern language, if I say some moose is really angry today, so be careful when you're going out, because you don't want to run into that moose, right? It happens, by the way. That's a real thing. I remember I was attacked by a moose going to the library once. I don't know why the moose was going to the library. I was the one going to the library. The moose wasn't going to.
Yeah.
That's that old joke, I shot an elephant in my pajamas. How he got into my pajamas, I'll never know. That's okay. Okay, forget it. Those are jokes. Definitely not on the same sheet of music with the class on jokes, apparently. They're supposed to be funny, so when you hear them, you realize, wait a minute, how did the elephant get in his pajamas? By the way, that could be because English works the way it does, that we can say those stupid things. Germans apparently can't do that. Because of the structure of German language. It frustrated the Monty Python crew when they went to entertain Germany. They had no laughter. All the Germans just sat there. It's like, what's wrong? No, in modern languages, when we say something about a set of things that doesn't actually exist, like a unicorn, a lot of people will argue, well, you can't actually have that statement true when you're talking about just, well, I'm not going to mess with it, but you get the idea. So the square has to be revised, and as a result, all the relationships that Aristotle did. Aristotle didn't have a problem with non-existing entity. So when we look to see how Aristotle handled that, not an issue, right? And today it is. So that's changed, and that's why we have that modern version of it. Not everybody uses the modern version. I hate it myself. So when I do logic, I don't really emphasize the modern version of it. But here's the problem with the square, though. When for you to have a true statement, you have to have the verb to be. I've not studied Asian languages. I mean, I had Chinese and Japanese thought years ago, and read a book on the Chinese language by Charles Carlgren, which was fascinating. It talked about the history of it and so on. But as I understand it, we had a professor from Beijing here years ago that gave a lecture and explained that the Chinese language does not enable you to use Aristotelian logic unless you study a European language or mathematics, because mathematics is actually works perfectly with the 2 plus 2 equals 4. For anything you pick, if it's 2 plus 2, then it's in the set of things that is for, right? So that's an A statement, basically. And mathematics fits the whole thing beautifully. Bertrand Russell will prove that, basically. But if you're speaking Chinese and you have pictographs, right? You know, a pictograph of a family, for example, which I don't know, crudely